So using this technique, this two-step estimation technique, we're able to estimate green matter and white matter, the kW to be 139 and 154 per minute, respectively. This compare very favorably to the Gregory paper reporting 136 based on T2 of the ASL, as well as early study 30 years ago using PET. So if you look at the histogram of the ratio, you will see actually about 80% of the water actually exchange into the tissue by the time of like a 1.5 delay. And if you look at the histogram of the KW, a majority of the pixel has a KW of 100, but there's a few pixels with the border number of 500, which is due to noise. So we have been applying this technology recently in clinical population, for example, obstructive sleep apnea. And why we were able to assess BBB function using this technology is because water actually is not freely diffusible across BBB. It only diffuses through BBB through this water channel called the aquaporin. And so by assessing the exchange rate of water, we will indirectly assess BBB function. And the OSA, is characterized episode of hypoxia attack, and it has been found, show significant brain damage, particularly in sites of autonomic, cognitive, emotional, and breathing function. So compromised BBB function has been hypothesized as a potential mechanism lead to brain injury in OSA. So we have an electric poster of the recent results. So we have 9 OSA and 9 control. There's no difference in BMI and gender. There's slight trend of age difference. What we measure is the CBF is not different and ATT is not different. However, we found actually the diffusion B50 over B0 ratio as well as the KW was significantly reduced, so indicating restricted water exchange in OSA. So this just shows you the numbers. Again, just repeating my last slide. You can see the transit time is on the order of 1.6 to 1.7 seconds, not much different. However, KW is reduced, and the ratio is also reduced from 0.8 to 0.7. CBF is not significantly different. So this is probably the first clinical evidence that shows this technology may be feasible. We're also starting to doing animal validation of the Piglet model of BBB disruption using a technology called focused ultrasound. This was done by my colleague, Kirsten Lawrence. So this shows you the piglet brain, and this is the focal ultrasound with the median conducting sound, conducting median. And we used 2 power level with 2.5 volts and a high power of 6.0 volt. And you can see with the high power, actually, you can cause hemorrhage in the piglet brain. The lower power is it's better, and this shows you histology of the piglet brain. And so far, the study is still ongoing. But so far, what we measured is we haven't seen significant change within this technology, although the numbers we're getting is very, very close to what we have been getting in the human. One of the explanation is this plot shows you the fraction of the basically the ratio of the B50 over B0 as a function of KW. So because at the resting state, normal condition, the water is almost all 100% exchanging into tissue. It's like 80 to 90%. So when you open up the BBB, it's not too sensitive at this portion. But if you have reduced the restricted water exchange, then the technology is more sensitive, as we see in the OSA. So these are all very preliminary results. How about in the future development? Definitely ultra high field. Why? Because this is you want to piece apart relatively small ASL signal into different compartments. You need a high SNR. So definitely you want to utilize the advantage, take advantage of the high SNR. And at ultra high field, there's great difference between the T1, T2, and the T2 star of the capillary and the tissue compartments. And again, you will have better sensitivity to the susceptibility effects, allowing concurrent estimation of oxygenation and the BBB permeability, as shown in the last talk. So this is a study by the Oxford group showing basically this is this animal study conducted at 9.4 Tesla with multiple echo, gradient echo ASL signal at multiple delay times. So this is the echo time, and this is multiple post-labeling delay. So they were able to estimate the exchange, water exchange time to be under of 370 milliseconds. So again, this is very close to what we've seen in humans. And at the same time, they were able to actually estimate the oxygen saturation of the arterial side. There's still challenge in terms of venous side. But they estimate actually the arterial side, the oxygen saturation is only 85% instead of 100%. So this is a very interesting study. In the humans, so far there's a lot of challenges for doing human ASL at 7 Tesla. Because of the B1 and the B non-inhomogeneity as well as SAR challenge. So we recently was successfully implemented pseudo-continuous ASL using this technology called a multi-band turbo flash, which is resistant to field inhomogeneity effects while still have low SAR. So this just shows you, with the multi-band, single band 3, MB factor of 3 and 5, you will get whole brain quantitative ASL map at 7 Tesla. So we have a power pitch Tuesday morning as well at the paper. Another interesting, direction is in the body organs. So this is a new study published by Xiang He last year. So he was doing is he tried to separate the different compartments in the kidneys. So using this T1 row weighted ASL. So the idea was because the filtration of the glomerulus is basically fill out the water, and the waste, but not keep the protein inside the blood. So we all know T1 row is sensitive to macromolecules such as protein. So he was able to separate the glomerular capsular space and the renal parenchyma based on this T1 row weighted ASL and estimate the single kidney GFR rate to be 49 milliliter per minute at baseline and increased by 28% after protein loading challenge. So the discussion is currently in vivo estimation of water exchange rate or permeability, I'll call BBB, is feasible, but it takes a long time because we need to measure multiple delays, multiple TEs, or multiple diffusion weightings. So there's the confounding factor of arterial transit time should be taken into account, estimation of water exchange. And the clinical value and the interpretation of the results still await further evaluations. And the future direction including ultra-high field as well as body organs. I would like to thank, first of all, my colleague, friend Keith Lawrence. He did a lot of work with the theoretical part as well as animal validation, as well as my colleague at UCLA to get the OSA study. Thank you.